Hey kids, today I'm going to talk to you about a principle called YAGNI, meaning you ain't gonna need it, and how this principle is behind a lot of the reasons why frameworks like Spring Boot, Ruby on Rails, or Django, that is, frameworks that promote convention over configuration, have become so popular over the years. Now, you ain't gonna need it means that you're not gonna you're gonna stop yourself from writing any code that you think is going to be useful in the future until the moment you're actually certain it's going to be useful, up until the moment you are going to need it. So what's so good about this principle? I mean, one might wonder, should we not be proactive and add every conceivable piece of functionality early on? And should we not be thorough and take full control of every single component on our application? And should we not optimize for performance? But here's why this might, more often than not, be a very bad idea. Every line of code you add into the system adds some sort of complexity, and it introduces the possibility for bugs. And for every single line of code, we need unit testing. We might need more documentation, and more important than anything, when a future developer comes into the project and tries to figure out what functionality they should modify to get their feature out, it's going to be a problem if you have all this boilerplate code, or if you have this useless fine-tuning of functionality and components and all that. So it adds to the maintenance cost of your code. So what we achieve by using convention over configuration frameworks is we defer to well-tested, commonly used libraries and frameworks, and we don't only gain the benefit of speed and convenience, but we also gain the benefit of not introducing all these nasty things I listed. And by hiding away the tedious nature of these tasks are common and repetitive, we can focus on solving the business problem at hand, instead of just dealing with tasks that have nothing to do with the task we've been given. I'm going to use a rather extreme approach to this principle by creating a small application in Spring Boot. And the idea behind this video is to demonstrate that the best code you can write sometimes is no code at all, or as little code as possible. So enough with the introduction. Let me quickly show you how to create this application. So we're here at start.spring.io, and what we can do here is we can generate the skeleton of our Spring Boot application. We can provide some initial parameterization, like the group name of our artifact and the name of our artifact, and we can, more important than anything, we can add the dependencies we need. So for this project we're gonna need this component over here, that effectively it handles the persistence layer of our application by mapping entity classes to database objects. We're going to need this dependency that maps incoming RESTful requests into entity level operations. So if you send a REST command to create a new something, this library over here will handle the translation between the network request and the database operation. We're going to be building a RESTful service, RESTful MVC service. So we're going to need this dependency as well. And finally, we're going to need some sort of storage engine. So we're going to use this H2 database, which is an in-memory database that is very commonly used in the early stages of development of a new application for prototype reasons, so that we don't really have to deal with this huge overhead of setting up a normal a standard database and the specifics of it and all that. So we just use this one and leave the details for later. Now we're gonna click on the generate button, and we've been given a zip file which we're gonna unzip over here, and then we're gonna open the project with our favorite ID, which in my case is IntelliJ IDEA. So we're gonna open the project over here. We're gonna select the pom.xml file and open as a project. Give it some time to resolve the dependencies and all that. And now let's take a look at what we've been given. First of all, we've been given a pom.xml file with all the dependencies that we selected earlier over here, and the Spring Boot Maven plugin, so we can build the project and the properties we set up. So let's close this one and not deal with it anymore. We've been given our runner class, where this is the class where the application starts from. You can identify it by having a main method and this annotation over here, Spring Boot application. We're not going to change anything out of here, but let's leave it open so we can use it later to run our application. We've been given a test class for it over here, which we're not going to touch at all for the moment. I'm not going to be typing the source code in because it's kind of boring to watch people, making typos. So let's just create our classes. First, we're going to create an employee class, and we're going to create a department class. So we're going to model effectively the employees per department relationship. So multiple employees belong to one department, and a department has multiple employees. So we have our two classes, and we're gonna need. Let's actually look at the source code for this. Sorry. So this is our employee class. First thing you should pay attention to here, the entity annotation. This marks, this is a Spring annotation, and it marks this class as an entity class, which is going to be useful in the context we're working on. So make sure this is marked on. Then we have four properties. First is the ID, which is marked with the ID annotation, effectively making the key, the primary key for this entity. We're just noting here how to generate the ID numbers, what strategy to select. Then we have two strings, a first name and a last name, and then we have a department object, which is annotated with a many-to-one annotation, marking and what it's trying to do here is trying to explain that many employees belong to one department. Let's move to the department class. You have the department class over here, again marked as an entity. Again, the properties are an ID, a name, and a set of employees. And again, the ID is marked as with the ID annotation. We describe how we want the numbers to be generated. And over here we have a one-to-many relationship annotated, and we have to be explicit on how the mapping works. So here you define the name. This one, you have to map this string over here with whatever the name of the property is over here. And Notice I'm not even going to write a constructor. I'm not even going to write getters and setters, because although it's kind of it's pretty standard that we're going to need them at some point. I definitely don't need them now, so I'm going to leave that for a later point. And again, the same thing here for the department class. And now we're going to need two interfaces, one for each class, one for each entity. So an employee repository interface and a department repository interface. And let's look at the source code for this. It's very simple. All we need to do is extend the CRUD repository interface that Spring provides, and you can see the parameters here is the employee class and the type of its ID field. So the type of this thing over here. And again, if we go to the department repository, it's the same thing. This time it's, the parameters are the department class and the type of its ID, which again is a long. And believe it or not, we don't have to write anything else over here. All the functionality is provided for us by this interface, which we can look at the code. So here are the methods. You can explore it if you want, but since the interface we extend provides all this functionality, we don't have to do anything. So these four classes are all we need to get up and running. So we can run our main method, and over here the Spring Boot container will the context will fire up, and at the very end you can see that we have a Tomcat web container started at port 8080. So we don't even have to don't have to do anything about the network layer either. The code we've written is it's just properties effectively. There's not a single line of functionality. There's no methods, not anything that we've written. Just described our entities and its properties and the relations of these entities. So let's test out our application. Let's fire up Postman and send some REST commands over HTTP. So let's first make sure that the application is running. You can see that if we send a GET request to port 8080, we'll get this response. So we have an endpoint here for employees and an endpoint for departments. If we were to hit those endpoints, we'll see that there's both employees and departments are just empty lists at the moment. So let's add the department by sending a post request to department's endpoint, and we're gonna need to send this JSON, describing the name, property, and the value of that property. So now we've been given an endpoint for department with ID 1, right? And if we click on that, if we were to hit this, you can see now. Sorry, not this. If we were to list the departments, we would now see, instead of that empty list, we would see over here that we have a department with ID 1. Let's also add an employee. We're just going to post some JSON to the employees endpoint, and the JSON will contain the first name and the last name. And again, we have a successful response. We now have an employee with ID 1. Again, you can pretty much see that we now, if we list all the departments, we have a department with ID 1 and an endpoint for its employees. So it already, by just looking at this response, it understands that there's a relationship between departments and employees. And notice the plural form here, that it says employees. This is because when we were defining the relation, we used a set, so a collection. So it understands that we have a, well, it's also in the variable name, but it understands that there's multiple here. Here are the employees. Again, you can see it understands the relationship between employees and department. Let's assign an employee to the department. We can send an HTTP put request to this endpoint, the employees. We provide the ID, and then we go to the we use the department endpoint. And what we're gonna need to send here is effectively a reference, to a RESTful reference to the department we're going to be assigning this employee to. So if we send this request, we'll get an empty response over here, but that which is actually good, it means it's a success, right? Now let's verify that this actually worked by listing the department's employees. Just sending a GET request to department with ID 1. You can now see that we've been given references to employee with ID 1. So we can do it the other way around. We can list all the department of this employee. And you can see that we've been given a reference to the department with ID 1. Finally, let's just delete the employee we built. Just send an HTTP delete request to the employee's endpoint with ID 1. Again, we're not going to get anything in the response, but we can just list the employees now, and you'll see that again we have an empty list. So all this functionality has been provided by, without even having to write a single method. And you can imagine, I mean, it sounds silly and it might don't sound very impressive, but imagine if you had to do this from scratch, right? You have to start by network programming, manipulating sockets, then parsing HTTP responses, probably parsing JSON, creating some sort of formatting for your dialogue with a client, then obviously creating the employee and department classes, and then you'd have to manage the database layer, and the database layer would then have to be implemented in JDBC, which is no fun at all. If you wanted an ORM framework in place, you'd have to work with Hibernate, so it's a lot of fuss just to get to this point. We can skip all that by using these libraries from Spring, and without a single method we can have this initial functionality. So now if we have a request that says if we have a request that says that one employee can be part of many departments, we can just come here and just change this. I mean, we don't have to, wade through thousands of lines of code. That's completely unrelated to whatever function, request we've been given. So it might sound silly, but it's not actually. It is very important to be able to just go directly to the task at hand. Yeah. So I mean, I understand that a lot of programmers have, might see this and just roll their eyes because we've been taught, that there's no fun, there's no pride in this, right? But try to imagine it the other way and try to be the developer that comes into the code that somebody else built 3 years after he's left the company. The person who wrote this initially does have pride in his huge components and all that, but when you go and take a dive into what he's built, you don't feel any pride. You just experience the pain on having to understand all this code and figure out, where the part you need to change goes. So yeah, that's pretty much it. Take care.